And for the partnership and the invitation out here to talk to Central Region. I always look forward to this, to connecting with you all here. And yeah, like Randy said, I really encourage feedback, and a lot of the updates this year have been driven by Central Region folks, so I really appreciate that. All right, so we're going to talk some quick housekeeping stuff about WSSI production. As we continue to mature, we're kind of considering WSSI as a suite of tools now, with the probabilistic WSSI scheduled to shortly go operational, and the prototype travel WSSI. We've kind of done a little bit of rebranding this year. The WSSI is still the WSSI, the thing that's been there this whole time. We're still calling it the WSSI. Occasionally, I'll put in parentheses NDFD because that's the driver. The probabilistic WSSI, we're now referring to as the WSSIP officially. And then the travel WSSI is going through a rebrand to the hourly WSSI with an abbreviation of the WSSIH. We're learning that if we put travel in the titles of things, it scares people. So we are moving to an hourly better, really talks about what's going on. It is an hourly forecast. So anyway, so now the three legs of the WSSI are the WSSI, the WSSIP, and the WSSIH. One of the big updates for the WSSI, the main WSSI, we're going to be kind of mostly focusing on that for right now, is the static images are being produced every cycle. If you remember the previous seasons, they were only updated like 5 times a day. We're the new VMs that we're running this on is fast enough that we can update this every cycle without issue. So static images are now up there every cycle, and they show up about 20 minutes or so after the web page is updated. Typically, we're seeing about 15 minutes after the hour WSSI updates, and 35 minutes after the hour or so static images are there. We have some new static state images this year. This is the full list. Some of the new, I can't remember if Minnesota was there or not all of last season, but Minnesota is there now. Missouri is there, as well as some other state perspectives outside of the Central Region. All right, let's move on. All right, so the suite of tools, kind of the status of where everything is right now. We've got the WSSI, of course, same thing. Main input is the NDFT, goes out from data 1 to 3, is operational. The WSSIP, remember that's the PWPF ensemble driven, or the WSC ensemble driven probabilistic version of the WSSI, using the same 60 members that we use to generate the PWPF. That is going to be operational at some point here in Q1 of 2024. The current date I have is November 25th, but that date has already changed once. So I think the safer thing is to say it's going to be operational at some point in Q1 of 2024. And then the WSSIH is going to remain an NWS internal prototype this season. We have a lot of promising development work that's led by Dr. Dana Tobin, who is a contractor here at WPC. She's doing some great work, and that tools continue to grow and mature, but it will remain internal this season. So what's new? I'm about to hit you with a lot of new information, but one thing I want to emphasize is that we're working closely with National Weather Service subject matter experts on these overhauls and updates. You know, I want to stress we're just not trying things because of reasons. These are all changes that are driven by feedback, and that feedback we're seeking out expertise throughout the Weather Service before trying stuff out on our own. And that's been a really fruitful effort. I think we've made some pretty impressive upgrades to the blowing snow algorithm. Big shout out to Tommy Gradenauer and Chauncey and Dan and all those guys up in the Northern Plains. We've really made some big strides there. And of course, big shout out to Brian Bargenbrock and Chris Sanders with some ice overhauls that we're going to talk about as well. So I think we've really worked hard to make sure we're establishing field partnerships, and that's helping out quite a bit. So what are some non-meteorological factors that are new this season? One of a big effort, once again led up by Dana Tobin this season, was to get some additional ice climatology or background grids, as well as some additional snow load information. And she was able to get some data and start an agreement with the American Society of Civil Engineers to get their snow and ice load information. We're using this to, how this data really ends up working is it paints a regional structural hardiness picture. And so we're using that to influence our ice and snow load grids. Currently, we're a lot of tree-based information, but this ACE data really helps out in regions that are not densely forested, like the Central Plains or in the South, the Southern Plains. And you'll see what this data looks like here. I've got some examples how this is really leading to some improvements where we're not just using flat thresholds throughout the whole CONUS. This is now scaled for regional hardiness, structural hardiness, I should say. We're also using the Enhanced Vegetation Index, which is a satellite field to help determine where there are green leafy things growing for the snow load versus vegetation not registering as leafy and growing. This is now replacing the old method of me, Jim, and Dana looking at data and deciding, yeah, the leaves have fallen. We're no longer the council that declared the leaves have fallen for WSSI. We're using actual data, so which is definitely an improvement. So we're using the EVI index is what it's referred to as, and big shout out to one of our contractors, Saddam Bonzo, who helped develop that input field. This updates every 16 days, so it's not perfect, and it does lag a little bit behind the current, but it's a much better picture of what's going on the ground than what we were using before. As I said, it's basically just saying where do we think things are growing, where do we think things are not growing, and we're using that to adjust snow load. We've also kind of gone back a little bit to look at the literature again for snow load. The literature directly points to a relationship between surface area and damage. Therefore, we're using about a 60% increase to impacts in the areas of vegetation where we do have that increased surface area. Otherwise, the base amounts are the same. In previous iterations of the WSSI, we actually ran 2 different versions of snow load and then mashed the grids together. Now we just have one algorithm, and where we see leaves, we're adjusting, and where we don't see leaves, we're letting the base algorithm run. We've also switched from, we're trying to get rid of just these purely yes/no grids and use a more densities when possible. We've replaced our old coniferous evergreen grid which was just pixels of where we analyzed there to be evergreen trees to a forest density. So we've spread those values out a little bit, and really we're trying to focus on where is the densest forest versus where do we have scattered evergreen trees. This, as I said, replaces that deterministic grid. The density is reclassified into different weights that we use for the calculations. This is going to help reduce those really sharp gradients we saw in the snow load fields. Sometimes we'd get some really goofy looking appearances that looked like it was influenced from non-meteorological data, and that's because a lot of the time it was this coniferous forest density. The land use has also gone through a little bit of an upgrade as well. We've increased the resolution of the land use that we're using, and we're also using, it's just like the AWIPS tool where we can do some grid smoothing, but we're smoothing these values out because what we're finding, the actual 2.5 kilometer chunks of land use data was really performing poorly in the cities, especially along the Great Lakes. There were some real issues there. So by smoothing these values out and reducing their the maximum decrease impact that they can have, the test cases we ran really showed a lot of promise there. Last year, you were allowed to decrease impacts up to 90% based on land use. We've capped that at 50% as we've realized that was way too harsh, and that the 90% was killing off some impactful situations. So we've really reduced that, and that has seemed to help in our reanalysis cases that we ran over the summer. This is a big upgrade. We're really excited about this next one. And once again, shout out to Chauncey and Tom and all the folks, and Megan and all the folks that we've worked with on this. But the blowing snow index and ground blizzard is now going to use durations of impacts as the nudger to move things to major or extreme. In previous iterations, it was just purely visibility based, but what we're working with now is requiring a duration of impact. We actually met up with that crew at the NWA this year, and we're discussing, how do we get this algorithm to align with what the field wants. And the biggest request they had was this concept of duration of impacts, which worked out well because Dan and I had already been working on that for a different project, but applying it to the blowing snow index and ground blizzard index is really going to make help us leap forward in what this algorithm is showing. So this is really up through moderate. It's going to really be focused on a reduction to visibility concerns. Major and extreme are now going to be reserved for these long duration events where we are expecting blowing and drifting conditions to be sustained for at least 12 hours and to get to extreme to 24 hours. And another big enhancement here is flash freeze and ground blizzards are now out to 72 hours. We ran some test cases and realized there was nothing to be afraid of, so we're running that out to 72 hours and not just stopping at day 2. I think that was the big things there. Yep. Okay. Switching gears quickly to the WSSIP. That is going operational November 25th. Probably. We'll see. We'll make sure that date doesn't change, but Q1 of this year is coming. Just as a reminder, what's going to be in this version, we're going to have rolling 48-hour periods in addition to the rolling 24-hour periods. So we kind of get more of a storm total sense of the impacts. GIS data is going to be available for each component and impact. This is going to just start off with shape files. The dissemination GIS group is working on a REST service. I've actually seen the test version of that, and it's really, really cool. It's really exciting that this is going to be released. And that will be available to the public and you all once this is operational later this month. And all these algorithm changes that we've been discussing have been carried through to the WSSIP. So let's look at some of these non-met factors that I've discussed before. This is an example. This is what the coniferous forest density input looks like. The darker shade the green, the more dense the forest, the bigger reduction to impact. As you can see, most of the really dense areas are reserved for the west. Cascades, Sierras, Bitterroots, all that. But we do have some of the more dense forest, of course, across the northern Great Lakes and up into the northeast as well. What you'll notice here, and now this doesn't really affect you all that much, but there's several species of southern soft pine that we used to analyze as coniferous forest. But the literature all clearly points to these southern soft pines as being extremely breakable. So we've removed those because they actually should be counting the other way towards they break easier than normal trees compared to coniferous trees. So those have been scoured out of our coniferous fields. This is what the new land use factor looks like as you approach the I believe it's as you approach the light colors here, there's no reduction to impacts. The darker green colors approach 50% reduction to impact just based on land use. And for the plains, doesn't really matter so much, and out east and out west, also pretty consistent grids with the forests and all, but where it really matters is in the cities and really the Great Lakes and the Ohio and Tennessee River valleys are all kind of a jumbled mess as far as land use is concerned. So this smoothing and increase in resolution is really going to help out there. So this is one of the new factoring grids. This is the ACE snow load factoring. The areas in pink out west and in the northern plain, or in the northern Great Lakes and Northeast, those are the resilient areas that are based on the tree densities. Basically everything in this wedge between the two main mountain chains are really heavily influenced by the snow loading factor. So what the climatology is really representing up here is going on in the north is there's no trees, but these areas are just used to like battering conditions. So they need to the structures up there are more resilient to snow loading than they are in, say, Austin, Texas. So this grid is helping influence that. So our thresholds for snow load are much higher across the northern plains than they are, say, across the Red River Valley in Oklahoma and Texas. This is the ACE ice amount forecasting. This is based on long-term mean recurrence interval data set. Basically, in the yellow, there's no adjustment because ice is very uncommon. As you get in towards navy blue, ice historically becomes more and more common. What we're doing here is we're just giving a slight nudging to the areas in yellow to functionally increase the ice amounts because it's unusual to occur. The areas in blue, there's no in the darkest blue, there's no artificial increase or decrease. There's no decrease at all of the ice grids. Let me make that perfectly clear. There's no decrease. You can only have a slight increase to impact in areas outside of that darkest blue. So for most of the central plains and central U.S., that's a slight increase to the raw ice values, but not a huge increase overall. So continuing on with some of these updates, ice, a big shout out to Brian and Chris, and we worked really closely with Brian on this. For ice accumulation, we're using the ice and wind methodology plus this ACE data set for regionalization. And we kind of have two trains going this year for ice. Minor and moderate are representative of impacts of surface transportation. So that we wanted to make sure that moderate is flagging for any kind of surface transportation disruption there. That is also aligned, the bottom of that scale is aligned with NWS thresholds. We've also, last year, we had a situation where there was no wind and the ice grids were allowed to slip through where the impacts were way overproduced. This year, all of our thresholds have been calculated for a no wind scenario and then are amped up based on the wind as well. But really minor and moderate, we want to stress that those thresholds have been set for travel impacts. Major and extreme are reserved for infrastructure issues, power outages, tree breakages. That's what we're reserving major and extreme for this year. So, and of course there'll be travel impacts in those situations as well, but that's our thinking for this year. For flash freeze, there's been two big updates. One extending out to 72 hours, and then the other, we've added a snow melt component to this. So this is we're using only using the latest 24-hour snow grid, and we're allowing that to say, hey, the snow can be melted here and refrozen. So there's a potential for black ice and other travel impacts based off this. But this is a short-term influence here, just in that with the first 24-hour snow. But this the snow melting is going to be an enhancement this year. We've already seen it be an enhancement early this season. The snow load we've really gone over already. Blowing snow we've really gone over already. But I wanted to stress here as well, all the components have now had a major update either in 2023 or 2022 last year. So all WSSI components they've all been revisited, and we think that the algorithms driving these are in the best shape they've been in thus far. I just wanted to quickly touch on some ice tables here, or some of the tables. Here are some of the amounts. Wanted to pull back the hood a little bit, so to speak. I wanted to talk snow rates, which you see directly in prob WSSI, but you also see baked into WSSI. These are our thresholds. Minor is starting at a ½ inch. Moderate is starting at 1 inch. Major is starting at 2 inches, and extreme is at 4 inches for pure snow rates. The base ice amounts, I have 3 columns here. The farthest column to the right is the Bargenbrock-Sanders impact value number. So while it's very cool and internally important, less important for this presentation, really I wanted to discuss these left 2 columns. I'm going to speak the common tongue and use flat ice as the amounts to report out, but I do have a column here representing what that correlates to in radial. Like I said, these first three categories, winter weather, minor, and moderate, are really focused on travel, and those thresholds are for winter weather area, any ice in the grids at all, a 1/10 inch of flat ice, a 1/4 inch of flat ice will get you to moderate, 3/4 of an inch will get you to major, and 1.5 inches will get you to extreme. And then for the snow load impacts, the literature also really pointed out that the shoveling or exhaustion level is really there. So we wanted to recognize that. So the minor threshold is really set to that for snow load impacts, just the shoveling factor. So the snow water equivalent threshold for minor is set at 1/2 inch. The winter weather area is set at 1/4 inch. And so that's really, really heavy wet snow for 4 inches is what that threshold is set to. And then once we get to the moderate, major, and extreme, that's all based on the coniferous snow load and ACE data that I presented earlier. One thing before we break for questions is the verification efforts going on for WSSI. We hear you that, hey, we need to have verification for this, and we agree. We're working on verification for this, and right now the best we can do is we're running an IRMA version, which is okay, but that still just tells you what they think the impact was, not what the observed impact conditions are that we forecasted or that we said. It doesn't necessarily tell you the ground truth of what the impact itself was. We say, hey, in 6 inches in Kansas City, if you get snow, that's a moderate impact. And if IRMA agrees, then okay, great, we have a verified impact forecast. But that still doesn't get to the heart of the question: does 6 inches of snow in Kansas City cause moderate impacts, or is that more major impacts, or is it minor impacts? So that's why we're excited that we're continuing our partnership and moving forward with MPINGs. Now, this isn't the end all. We know that this is just another layer of data that we can use to help paint the picture of hey, are people seeing real impacts or not? So I really encourage everybody to use MPINGs this year and if, report this out to the partners. We have a complete separate category called in the MPING app called Winter Weather Impacts. And from that menu, you can choose any of these impact options that we will have access to, and we've kind of broken down into this scale on what we think they look like as far as how they map to our WSSI scale. But this is going to help us start to paint the picture of, all right, where do we really see impacts, and how are these lining up? So we're moving in that direction. We're trying. This is another step. We know it's not going to be perfect. There's all the caveats in the world with MPING data, but it's another positive step, and we're really excited about that. And last year, there was basically no advertisement that we did this, and what this image shows is all MPING data overlaid on top of the maximum WSSI impact at any given point from last season. And hey, it did an okay job. It's not perfect, but with a little more advertisement and a little more buy-in this year, we think we could at least have a 50% increase in reports and from MPINGs, and then we could really start to do some interesting things with the analysis, like look at impact density. How does that work for the more rural and urban areas and all that? So anyway, MPINGs should really help us with our verification efforts this year. Quickly, there's some hourly WSSI algorithm changes. The blowing and drifting snow impact levels are coming. The impacts are tied to computer reductions in visibility there. The hourly WSSI is currently running a little bit too hot. We looked at several cases from last season, and we're like, it's a little hot. So Dana has turned down the knobs a little bit. So the biggest change is the influence of these factors, like the accumulated impact factors that she has built in can only total up to a 25% increase before it was allowed to go over that. So it was over ramping up some areas. So this cap on total increases has shown to be very useful in our internal testing. And that web page will be restored and up running here again at some point in November. Yeah, expect that in time for use for most of the winter here. I have some appendix slides in here showing some of these are very much keep these internal. And then I also put our WSSI snow climatology back in here so people can have access to these grids as well. And with that, I pass it back over to you, Randy. Thank you again for the invitation.
Thanks, Josh. Really appreciate it. Great information. If you have a question, please raise your hand or type it into the chat. Hey, Josh, are you going to be making this presentation available so folks have access to those last few slides in particular that you just showed?
Yeah, actually, I was going to ask you the best way to do that. I can email it to you or Alex or whoever.
Yeah, why don't you email it to Allie and I, and you can drop it right here in the chat too for those that are interested.
Yeah, that's true.
And you did get a couple of requests in the chat from Iowa and Indiana, by the way. So, Andy, go ahead and ask your question.
Yeah, really quick on that ice, and this might be an appendix item. I noticed that the ice threshold was 1/10 of an inch for the minor, and I just seen many freeze and drizzle cases that are just and only maybe a couple hundreds at most and cause many travel hazards with lots of accidents in that. So I just wondered if you could comment on that.
That is, oh boy, yeah, freezing drizzle. We are. I cannot wait till we're able to do more with that. I'm going to throw it to Brian. Brian, you figure out how to do freezing drizzle, and then we'll get that in here. At this point, we really have no awareness to that. Unfortunately, I think I would not rely on just being completely honest, I would not rely on WSSI for impacts for freezing drizzle situations this year. We're going to be blind to it. Those will probably still show up as winter weather areas, and I completely agree with you that they can be just as catastrophic as even to the travel situation as a 1/4 inch of an ice. But we don't see that yet. WSSI does not have the capability to see that yet, but we will continue to work towards an inclusion of that. But honestly, we're just not there yet.
All right, great question, Andy, and thanks again, Josh. Really